Neil Battaglia, Neilian.com. This video is about solving using the quadratic formula. So if you have a quadratic equation, that means that the largest exponent is a 2. So for example, x squared plus 2x plus 1. You can use the quadratic formula to solve it. And usually it's going to be 3 terms, what's called a trinomial, so x squared plus 2x plus 1. It could just be something like x squared minus 2, or x squared minus 4. So basically for those, you have one term missing, but what that really means is the coefficient for the middle term, or for the last term, is going to be 0. So if we have, let's go with x squared plus 2x plus 1. There's a coefficient in front of each of those terms. The last term kind of is just the coefficient because it's just the number. But in front of the x squared, you could think of there being a 1. In front of the 2x, the 2 is in front of the x, so the coefficient is a 2. You could also have 2x squared plus 3x plus 3, in which case you would have a coefficient that's different than 1 in front of the first term. So what we do is we get the quadratic equation, we make sure that there's terms on one side with a variable, usually x, could be something else. On the other side, there's going to be a 0. So these things are equal to 0. You're finding when the equation crosses the x-axis, where y equals 0. So the equation has 3 terms usually, and we can label the coefficients as ax squared plus bx plus c. So the things in front of the variables and then the final number. The quadratic formula isn't too hard to derive. I could do that in another video if you're interested, but basically we're going to go into using the quadratic formula. So what you can do is you can use the coefficients from the quadratic equation, the a, the b, and the c, and you can say that minus b plus or minus the square root of b squared minus 4ac, the whole thing divided by 2a, is going to be equal to the x coordinate of a solution. So I'm going to go through a few different examples. There's kind of some tricks you can use. For example, if you had something that you can factor by 2, you can factor out a 2, you have a 0 on the other side, you divide both sides by 2, and you probably get numbers that are easy to work with, as long as you keep whole numbers in the process. And if you have something inside the discriminant, the part inside the square root sign, the b squared minus 4ac, if that ends up being negative, then you end up getting imaginary numbers, and your solution is probably going to be complex. So that means complex is a combination of real numbers and imaginary numbers. Let's use the quadratic formula on a few different quadratic equations. So in general, we have ax squared plus bx plus c equals 0. We got the a, the b, and the c. And then we can use the quadratic formula, which was minus b plus or minus the square root of b squared minus 4ac divided by 2a. The parts within the square root symbol are called the discriminant. So here's the first example, x squared minus 2x minus 15. You could also solve this particular one by factoring, and you might want to do that just to check your answer. So a is equal to 1, b is equal to minus 2, and c is equal to minus 15. Okay, so the first part we see is that we've got a minus b in the quadratic formula. So since b is equal to negative 2, we're going to make it a minus minus 2, which becomes plus 2. We've got plus or minus, and then plus or minus these parts in the square root symbol. So minus 2 squared minus 4 times 1 times minus 15, and it's all divided by 2. So we get plus 2 plus or minus 4 plus 60 over 2. We combine the 4 and the 60 to get 64. And we know that the square root of 64 is going to be 8. We've got 2 plus or minus 8 divided by 2. So that means we have 10 over 2 or minus 6 over 2. And those both are even numbers divided by 2. So they reduce to 5 and negative 3. And those are just the x coordinates, but since we have the equation equal to y equals 0 in the first place, we know that the y coordinates are going to both be 0. So it's 5, 0 and negative 3, 0 for the solutions. If we want to confirm that, we can look at x squared minus 2x minus 15. We can plug in the results we just got. We get 25 minus 10 minus 15 is 0, and we get 9 plus 6 minus 15 is 0. So it works. You can check it if you want to. You might want to check it to see if you made a mistake, but if you haven't made a mistake, it should basically get you 0 for the y-coordinate. Okay, here's another example. 2x squared plus 3x plus 1. So a is equal to 2, b is equal to 3, c is equal to 1. And again, the equation is equal to 0. So minus 3 plus or minus the square root of 9 minus 4 times 2 times 1, and it's all divided by 2 times 2. So we have minus 3 plus or minus square root of 9 minus 8, that's divided by 4. 9 minus 8 is 1, so, and the square root of 1 is 1. So minus 3 plus or minus 1 divided by 4, you get minus 4 over 4, or you get minus 2 over 4. If you reduce those, you get minus 1 or minus 1/2. Another example, 2x squared plus 6x plus 4. Now this one we can do something a little bit different. Since the two sides of the equation are equal, you have an equal sign in between, you can actually do the same thing to both sides and they'll still be equal. So you could add 2, you could add 3 to both sides, you could multiply by 5. In this case, I'm going to divide both sides by 2. 0 divided by 2 is going to remain 0, but the even numbers on the left side will reduce. It's usually easier to deal with smaller numbers. So if you see a quadratic equation that has all even numbers, you might want to divide everything by 2. It might be convenient. Or you might want to divide by like 4 or 5 or something else that makes it so you have numbers that are a little bit smaller. If you're going to be using the quadratic formula, basically that means you're not just inputting it into a computer or a calculator to get the answer, so you probably want to make it simpler. If it's simpler, you'll probably avoid some mistakes you might make if it was more complex. So you end up with x squared plus 3x plus 2 is equal to 0. Our a is 1, our b is 3, and our c is 2. So you could have used b as 6, a is 2, and c is 4, but I think it's going to be easier if you do this reduction. Again, it's optional, but it might be useful. So minus 3 plus or minus 9 minus 4 times 1 times 2, divided by 2, we get minus 3 plus or minus 1, because 9 minus 8 is 1, square root of 1 is 1. So you get minus 1 or minus 2 as your solutions. Here's another example, x squared minus 9. Now this looks a little bit different because it's a binomial. It only has 2 parts instead of 3 parts. So you might think that b is equal to minus 9 because it's the thing that comes after the x squared. But the b is really the thing that comes in front of the x, and we don't see an x. So that actually means that b is equal to 0. And c is equal to minus 9. You might recognize this as a difference of perfect squares. If you do, you could probably factor it and get the answers a little bit more quickly, but we can go ahead and use the quadratic formula just to try it out. So b is 0, I'm just not going to write it at first. So plus or minus the square root of b squared, again 0 squared is 0. So minus 4 times 1 times minus 9 divided by 2. We get plus or minus root 36 over 2, so we get plus or minus 6 over 2, we get plus 3 or minus 3. Another example, x squared plus 3x plus 10. This is going to maybe be a little bit different, but we'll see why. So the a is equal to 1, the b is equal to 3, and the c is equal to 10. So we get minus 3 plus or minus square root of 9 minus 4 times 1 times 10, and it's divided by 2. So that ends up being 9 minus 40 in the discriminant. 40 is bigger than 9. You're going to get a negative number. So you get minus 3 plus or minus the square root of negative 31, which basically is not going to give you a real number, divided by 2. But if you're to the point where you're dealing with complex numbers, imaginary numbers, we can go ahead and use that. That's fine. So I'm going to say the square root of 31 times I, and it's divided by 2. I think, yeah, 31 is a prime number, so we're going to leave that alone. You could potentially say minus 3 over 2, and then plus root 31 I over 2, and then the other version with a negative sign. And sometimes this will actually reduce, so it looks a little bit simpler. So you might have like 2 even numbers on the top, and you're dividing by 2, so the 2 can be kind of removed by dividing. So those were a few examples for the quadratic formula and using them with quadratic equations. Let me know if you have any questions about the steps, and I could do a follow-up video if you're interested.